A student forgot to add the reaction mixture to the round bottom flask. Okay. So I have a round bottom flask at 27 degrees Celsius. But instead, she placed the flask on the flame. Okay. After a lapse of time, he realized his mistake, and using a pyrometer, he found the temperature was so much. Now, apparently, this round bottom flask was there. Initially, it was this much. And finally, the stupid flask has been heated to 477 degrees Celsius. There is some flame here, etc. What fraction of air would have been expelled out? Now, it is an open flask. So, as you heat it, air from it ejects out. Yes. Do you note that what is the volume of air in the flask? How do I count that? I just imagine that, see, this is kind of the boundary, and whatever are the number of moles of air contained in it, that is the air contained in the flask. Since it is open to atmosphere, and are you aware that whenever you're talking about atmosphere, atmosphere is always at a constant pressure of 1 atmosphere unless mentioned otherwise, right? So for both these flasks, volume is constant. Pressure is 1 atmosphere, which is constant. Why? Because since it is open to air. Oh my God. What is changing? What is changing is number of moles. Initially, I had some N1 moles of air and temperature was T1. Now, certain number of moles have ejected. So now I have N2 moles of air and temperature is T2. Right? Fine. Can I find relation between N1, T1, N2, T2? I can. Why? See, PV is equal to nRT. Now pressure is same, volume is same. So I can say N1 T1 is equal to N2 T2. So moles initially by moles final is temperature final by temperature initial, and final temperature is 477 degrees Celsius. 477 and 273, if you add, you get 750 Kelvin. So final temperature is 750 Kelvin. Initial temperature 27 degrees Celsius is 300 Kelvin. How much is this ratio? This comes out to be 2.5. So initial and final moles, the ratio is 2.5. And what they have asked you is what fraction of air would have been expelled out. So you can say fraction of air expelled. Can you find the expression for it? Yes, this is moles of air expelled by moles of air initially. Whatever is expelled divided by whatever was with the initially, that is fraction expelled. Now what is there initially? Ni. I stands for initial. So denominator is clear. Initially it was Ni. Finally it is Nf. So what is expelled? Whatever was there minus what has been, what remains. See, how did I get this? I repeat, initially I had some number of moles. Finally, I am left with some number of moles. The difference is nothing but the number of moles of air expelled. Otherwise, why will final be different from initial? Final is different from initial because some moles have been thrown away. Yes, good. I have a relation. Of course, I have a relation. N final is 2.5 times, no, so 2.5 times N final is N initial. So N initial is 2.5 N final minus N final upon 2.5 N final. Oh my God, this is cancelling, yes. And this comes out to be 1.5 by 2.5, which is 0.6. Fraction of air that has been expelled out is 0.6, or if you want to convert this to a fraction, 3 by 5. 3/5 of the original air has been expelled because of this heating.